Hey, Joel. Good to talk to you today.
Hey, Ian. Nice to be here.
All right, so really excited to talk to Joel Anderson. He's our EVP Advanced Analytics at Dig Insights. Joel, can you start off by kind of telling us a little bit about what your department does at Dig?
Sure. Yeah. So I run the Advanced Analytics team at Dig Insights, and we're an internal shared services team within the organization. We support our client service and insights roles at Dig, and we'll run the gamut of all kinds of advanced analytics here, from relatively straightforward factor analysis to much more complex simulated shopping experiments, building the designs for those, and then running the statistical analysis and simulated projections at the end of that. We also do, one area that I'm really excited about is we do a lot of automating some of the advanced analytics that our company does, like network map visualizations, turf analysis, share of choice simulators, things like that. And we work with the tech team on the UI UX development to figure out how to engage with a user and the kind of algorithms that go into the analysis behind that. We contribute to those as well.
I think that's really interesting thing that we do differently at Dig, and I give the credit to you, Joel, because you were really the pioneer of our approach, which is that, in some cases we will use off-the-shelf stats packages or open source stats packages, but we always aim to sort of own our own algorithms so that ultimately we can build things into tools so that you don't have to go, either you do not have to go through an analytics department and slow down your process, or it's tools that the analytics department uses yourself to speed up the time to get to an answer. And I think that's a big difference between what we do and what other research companies do, where they just always use the analytics department as just a desk service. You're not just a desk service. You go out, you build new approaches, new tools, new algorithms. You take existing algorithms, you rewrite them in new ways that might be faster, better, more exhaustive, whatever it is. And I think that's a really cool thing, and that's an approach that I think that you brought to the company. So kudos to you for that.
Yeah, thanks. I mean, it's the stuff that I'm most excited about. So I enjoy that the most.
So, is that the thing you like the most about your role? Is that freedom to, not just deliver a result, but also make sure that it's replicable?
For sure. Like one of the things at Dig, one of the things that's really core to our being is this notion of excellence and evolution. We really strive to continually improve on what we've built already, and part of that is if we can automate analysis and democratize it so it's in the hands of all of our insights, like the client service leads at our company, then we're able to focus more on the higher level thinking and building new tools, as opposed to just grinding out some of those analytics that we could have just run automatically in the first place.
So let's talk about some of those either tools, algorithms that you're writing. What's some of the more interesting challenges you've had in the last little while?
Sure. Yeah. So one thing that we see constantly is our clients are always pushing the boundaries of trying to put more into an experiment than is traditionally considered possible or a good idea. And so one way that we manage that is instead of just throwing everything in the kitchen sink into a model, what we've been doing to reduce the errors in our model is if we use off the shelf technology and the commercially available software to do our models, we don't have the flexibility to code up our models in certain ways. But if we build them ourselves, we can code them up in certain ways so that we can more sophisticatedly analyze the data and reduce the amount of error in our projections, which means our clients are getting a more actionable and accurate model on the back end.
Right. And so when you're talking about model, you're talking about things like volumetrics, source of volume, sometimes it could be a conjoint analysis, could be predictive models.
Exactly. A
Yeah.
good example is, sometimes our clients, will ask us to include something like a change to the ingredients on the back of the label of a package that's on a shelf in a grocery store. And so that's the kind of thing that most consumers are not looking when they pick something up and buy it off the shelf in everyday shopping. And so when we do that type of analysis, we don't necessarily want to call it out to our respondents, because if we do that, then we bias them towards considering it, and we get larger effects than if we didn't do it otherwise. But if we don't do that, then most people don't notice it at all. And so what we do is what we can actually model, though, if we just do that into traditionally available commercial software, then we would have a lot of error in our model. It would add a bunch of noise where it thinks that, because it sees that I bought it twice out of 5 times, it thinks that it's something I really like. But I only saw it 5 times because there's a limited amount of times you can put someone through a simulated shopping experiment before they get fatigued and bored. And so what we've done is we've been able to use new algorithms that we've written ourselves to reduce the amount of error and shrink the variance in those results, so that we don't have a bunch of noise in our projections. And so at the end of the day, when our clients say, well, what's the effect of me changing this ingredients list? We don't have this wild change that might go up or down miscellaneously, by a larger margin than it should be. We get to the true actual change by doing those sophisticated algorithm tricks that I'm talking about.
So, and I think what's also interesting is that, you've been doing this for over 10 years now, that, building complicated, choice-based models, prediction models, segmentation approaches and models, predictions. And one challenge that we've always traditionally had is that not just needing to democratize it, but even just the amount of time that it takes to run the models themselves. I remember early days, you and I working on some projects, and you were like, okay, well, I'll get what did we used to call the computer in the office, the server we used, Heisenberg or
Heisenberg.
something?
Yeah.
Heisenberg. You'd say, yeah, I'm going to put it on Heisenberg and we'll check on it like tomorrow, because
Yeah.
it's just going to run all night. And that was like, that always bothered you, which I loved. Like, you didn't just have this approach like, okay, well, my job is just the math. I don't care. I'll tell you it's going to do whatever billion rotations or exhaustive Monte Carlo or something. I'm going to actually speed this up, because we know that we need to automate things. We need to be able to get to answers faster. So I'd say a lot of your time this year has been spent on really deep, like, algorithm, like, like speeding up methods. Is that fair to
Yeah.
say?
Yeah, that's right. Yeah, the last couple of years has been a really, as we grow and scale our company, the need to model faster is becoming greater and greater, as we get more and more projects and do different types of quick turnaround studies. And there's nothing worse than having a model that takes 2 days to run, and then the day before it's due, the client comes back to you and says, this I made an error. This product needs to be removed from the model, and now you need to rerun it, or some situation like that, or there was a coding mistake in the interface, and now you have to change what price people saw and rerun the whole model, and then you don't have time to do it. And so being able to have a faster algorithm gives us that flexibility. And also, as we automate more and more, if you're giving people access to a self-serve tool, and which we're doing through Upside now, that has sophisticated modeling on the back end, people are used to, especially with DIY tools, they're used to getting immediate feedback and results right away. And you can't just tell them, oh, come back in 8 hours or come back in 2 days. You want to get that done as fast as possible. And so one thing we're doing is we're borrowing from different industries, like the tech industry, AI, machine learning, and in those industries, they have these large neural network problems that require tons of compute power, and they just weren't possible until more recently when NVIDIA's really pioneered using GPU acceleration to parallelize a bunch of math. And, without going into a bunch of detail, these techniques have been around for, a decade or so. And we're taking advantage of the learning and the sort of pioneering that other industries have done. And we're using the GPU acceleration on our side for speeding up our models too. And
Gets us into a
that's
much better place to be able to get those answers
yeah,
faster. And you're also probably stumbling because you can't say too much because some of the stuff that you're working on,
yeah,
we're in patent process on. So I'm not going to go
yes,
down those roads, but
thank
very
you.
exciting stuff. And it's like it enables us to get to, to do things that other analytics firms, even not just research firms, might take them days. You've cut down to minutes, in some cases, even seconds. So
Yeah,
amazing stuff. Beyond, the interesting thing, the conversation that I had with you, I guess was it last year? I don't know. I'm bad with time, but having I myself have been head of analytics. You've been head of analytics at Dig for I think like 10 years now. And you were always, one of the most sophisticated analytics professionals that I've ever met. Like you're so, you know, miles beyond what I knew when I was doing a role similar to yours. And then you said, and in my spare time, I'd like to go take a master's degree in artificial intelligence. And I was like,
yeah,
first of all, what spare time? But
yeah.
how's that going? How's that master's degree going?
Yeah, great. Yeah, yeah. So I've been doing it for the last few months. I've finished a semester so far, and I have four remaining. And it's been going really. It's been going great. It's funny going back to school as a mature student. When I was in school the first time around, I didn't. I tried to an extent, but I usually studied kind of the night before type of thing. But in my professional career, I sort of realized that the more you put in, the more you get out, and it's very rewarding to really understand how things work. And so as I'm going through my schooling nowadays, getting great marks because I just care a lot more, and I find that if I know how everything works, it really benefits me in my day-to-day job and helps me with my with my career, not just in my schooling. And so I'm really enjoying it. Find it really interesting, and it's nice to get good marks. I gotta tame myself a little bit on my effort time put into it sometimes, but I'm really enjoying it. It's a lot of fun.
So what have you learned at all that you've already found applicable? Um,
Sure, yeah, like all kinds of stuff. I mean, one thing that I've loved to see. So one thing that I'm really loving is that like almost everything I'm learning is applied. Every week we cover a different module in my program, and everything that I've learned probably every week has been applicable in some fashion or another. And one of the most applicable, I would say, was we did. We had a few weeks on Bayesian networks, or some people call them Bayes nets, and different ways of doing. And so from AI's perspective, there are different ways of looking at how agents interact with the world, and for our applications, there's various ways that we use Bayesian networks with looking for causal discovery for things like what the effects are, or what's the cause and effect relationship with a dependent variable, like you know be a consumers being likely to recommend a product to their friends or family, like a traditional NPS question. And as I was going through that, one of the papers that I read was about using Bayesian networks in environmental research, and the effects that what they did was they looked at they did a survey of open-ended people with general population and researchers and other people, and they asked them their attitudes towards climate change, and whether they're going to take action on various changes or not in their life. And it's really interesting to look at how researchers in other industries are using Bayesian networks with open-ended text data, and how we might be able to apply that, because obviously we're a survey research firm traditionally, so how we can
So
apply that internally.
beyond just the traditional, I'm going to translate, or what's the word for it? Get a typed transcribe an open end, and then group an open end, and then maybe do something like like sentiment analysis, or something like clustering based on theme. Even beyond that, actually using that data now in predictive models itself, as though it's more traditional quantitative structured data, right? And so you're actually looking at ways of building predictive models out of unstructured data at this point.
Yeah, so we can take a bunch of verbatim response text that our respondents give us in a survey, and we can extract all the topics that they've covered in their text, and we can look at the run a Bayesian network on that, and any other data that you want to include in the model, and look at the cause and effect relationship that people that like the network of cause and effect relationships that the Bayesian networks show, on all the topics that people pull out, and whether that's going to have an effect on their, whether they want to take action on climate change or not.
Amazing. So, I mean, I could talk to you forever with that kind of stuff. You and I do talk regularly about, ideas and new approaches to things, and we could go into a million different rabbit holes, but really, I just wanted a quick touch base with you, let people know what you're doing and how what you're doing at Dig, and talk about some top line, big exciting things you're working on. I mean, everything you're working on is exciting, but I really love the stuff you're working on lately, and it's, again, just seeing the results, like seeing what you're able to do with relatively sparse amounts of data is kind of amazing. And we've been building more and more models around less and less collection in new and exciting ways that I think is different from what everyone else is doing. And again, that bent towards democratization, automation, building our own tools, building our own algorithms, and then pushing those out to both inside and outside of the organization. Again, huge kudos to you. It's unbelievable the stuff that your team has done. So thanks so much for chatting with me today, Joel.
Yeah, thanks for having me on.